Hello. In this video, we're going to go through problems 12 through 15 from the North Carolina Common Exam for Math 2. You can find more information about this common exam and all the common exams from elementary school all the way through high school at this web address. Let's get started. A company manufactures DVDs. The company spent $247,000 to develop its process for manufacturing the DVDs. The company spends an additional $1.25 to manufacture each DVD. Which function represents the average total cost per DVD, Y, for the company to manufacture X total DVDs? So now that I have read it once, I'm going to go through and highlight key information. So how much they spent to develop the process is probably important, so let's highlight that. And then they spent an additional $1.25 to manufacture each DVD is also important. Our variables are important and what they represent. So Y is the cost per DVD, the total cost per DVD. You got to put the whole thing in there. And for the company to manufacture X total DVDs. So X is my total number of DVDs. All right. So we're writing an equation to model the total cost here. So the total cost is Y. And starting out, they start out already $247,000 in the hole. So I'm going to go ahead and put that down, $247,000. And I'm going to kind of model the way they do over here. The 247 is on the back part. You can put it in the front if you want to. It's just going to be adding to other things. But I want to put it back here just to make it look like these. Alright, so it's $247,000 to start out with. Now, each DVD that they make costs an additional $1.25. So that adds to their total cost. So it's $1.25 times the number of DVDs they make. That's going to be added to the original price to develop the process. Now, they're not wanting just the total cost though. They're wanting the average total cost per DVD. So to find the average, you have to divide it by the total number of DVDs, which was X, and that gives us their answer, which is, for this question, D. Number 13. For a carnival game, a jar contains 20 blue marbles and 80 red marbles. Children take turns randomly selecting a marble from the jar. If a blue marble is chosen, the child wins a prize. After each turn, the marble is replaced. Casey has drawn 6 red marbles in a row. Which statement is true? Alright, so in this problem, there are several things that we have to take into account. They're all important. Some parts that may be a little bit more important to us than others is the fact that there's 20 blue marbles and 80 red marbles. Okay, so we've got 6, well, looking at these, other parts that are important in this, thinking about probability, you want to know a couple things. First off, do you replace the marbles after each turn? Okay, so that's this part right here. After each turn, the marble is replaced. Alright, that's actually the most important part that we're looking at here. Okay, because if it is replaced, then drawing a marble won't affect the next draw. If it's not replaced, then drawing a marble does affect the next draw. Alright, so in theoretical probability, which is what this is talking about, your probability is the same every single time, no matter what's drawn before. So the fact that Casey has drawn 6 red marbles in a row does not mean that they're going to have any better or worse chance the next time of drawing a blue marble. Alright, so looking at the answer choices here, selection A says, if Casey selects another red marble, then 2 of her next 3 picks will be blue marbles because 2 blue marbles are selected for every 8 red marbles selected. Okay, once again, since we're replacing the marbles, it doesn't affect any of the next picks, so that one's not going to be the answer. B, the probability that Casey selects a blue marble in the next turn is higher than it was on her last turn because she has chosen so many red marbles in a row. Once again, since we're replacing the marbles, it doesn't affect the probability at all, so that's going to be not the answer. C, the probability that Casey selects a blue marble on her next turn is the same as it was on the last turn because selections are independent of each other. That's a winner. Okay, it doesn't affect the probability at all since we replace them. Alright, let's go ahead and read D anyway. If Casey draws 4 more times, she will select 2 blue marbles because the probability that the blue marble will be selected is 2 out of every 10 turns. That's also not it, okay, because each time she puts back, so it's not going to affect any kind of outcome in the future. All right, number 14. A plane intersects a regular triangular pyramid. The plane is parallel to one of the faces of the pyramid. What type of polygon is formed at the intersection? All right, so here we have a regular triangular pyramid. So I'll try to draw. All right, the bottom is a regular triangle. That means all sides and all angles are congruent. So when we draw the pyramid, I'm going to try to draw it to where it looks halfway decent. That's horrible. Let me try again. That's going to look better. All right. So this is being intersected by a plane. In other words, we're going to cut the part of the triangle off. We're going to look at what kind of shape it makes. Now it says the plane is parallel to one of the faces of the pyramid. Well, if it's parallel to the base, it's an equilateral triangle. Now, equilateral triangles have 3 sides that are congruent. If it's parallel to one of these sides, though, if you cut it this way, all right, so if we make, and this is the plane right here cutting that side, it's going to have, it's going to have 3 faces because you've got where it intersects this side, where it intersects this side, and where it intersects this side. All right, so it's still going to be a triangle. And that one point where it intersects is going to be kind of slanted, make 2 of the sides longer. And that third side's still going to be the same size. All right, so it's going to make a triangle that looks kind of like this. All right, so these 2 sides will be congruent. All right, so either all 3 sides will be congruent or 2 of the sides will be congruent, which means it will always be an isosceles triangle, which is D. All right, number 15. The number of bacteria in a culture can be modeled by the function n of t is equal to 28t squared minus 30t plus 160, where t is the temperature in degrees Celsius the culture is being kept. A scientist wants to have fewer than 200 bacteria in a culture in order to test a medicine effectively. What is the approximate domain of temperatures that will keep the number of bacteria under 200? All right, so highlighting key information in this word problem. We've got number of bacteria is modeled by the function. The function's important because it lets us know how many bacteria are in that. N of t is the number of bacteria, and T is the temperature in degrees Celsius the culture is being kept. So N is the number of bacteria, T is the temperature. Now, I don't think they're going to have us go from Celsius to another way to measure temperature like Fahrenheit. So skimming through it, I don't see Fahrenheit anywhere, so I'm just going to leave that as it is. We don't have to convert. Scientists want to have fewer than 200 bacteria in a culture in order to test medicine effectively. What is the approximate domain of temperatures that would keep the number of bacteria under 200? Now, we can do this one a couple of different ways. We could set up a inequality and solve it to find the domain, and that would look something like this. We want fewer than 200, so we want this to be less than or equal to 200. Well, not even equal to. We want fewer than, which means absolutely has to be less than. Okay, and so I'm going to put my function on the other side. 28t squared minus 30t plus 160. Give me just a second. I messed up the page again. All right. All right, so once again, 28t squared minus 30t plus 160. Now we could solve this using our quadratic formula or whatever other method you want to use if you can. Well, you can't factor this because these are going to be decimals. But you could solve this and it'd be fine. What I like to do though is I like to look at these things graphically. We have a function over here that we can graph, and then we can set y equal to 200 and see where this is less than this. And that's what I did, and that's what I'm going to show you how to do on your calculator now. So first thing you got to do is you got to press the y equals button right here. And that brings up this menu. You plug in one side of the equation or inequality in y1, plug in the other side in y2. For this particular problem, I know the y value is going to go up to 200. We're looking for everything under 200, so I want to set the y max at least 200. I like setting it higher so that way I can see where it intersects. So I'm going to put that at 300. You may also notice that I changed my x-min and my x-max. The reason why I did that was looking at my answer choices. I see that none of them are less than -2 and none of them are bigger than 3. And so I made my x values reflect that. Next, you're going to press second and then the trace button to get to the calculate menu because we want to calculate something about our graph. We want to calculate where these two intersect. So you select option number 5 and it brings up a window that looks like this. Alright, it'll say first curve and second curve. Now since we only have 2 graphs in there, you can just hit enter for both of those curves. When it says guess, you need to go to the intersection you want it to calculate. So I scrolled over to the one to the left first. When you press enter again, it'll tell you your actual intersection. Okay, so when x is approximately -0.77, that's where it intersects. That's where you have 200 bacteria. Then from there all the way to this other intersection, the number of bacteria is below that line, which is 200 bacteria. So we do the same process. We go second, trace to get to the calculate menu, option 5, enter, enter, enter. On that third enter though, before you press it, you want to scroll over to the other intersection to get it to tell you the other intersection is x equals 1.85. Alright, so that means between -0.77 and 1.85, that's our domain that we want to keep the number of bacteria under 200. So looking at our answers, that's going to be D. Alright, that's all the questions for today. If you have any questions, feel free to leave a comment, and have a good one.